Welcome to Engineering 5.0. Here I cover anything and everything about engineering. This particular video is about how to install basic RISC-V tools so that you can start to play around with the tutorials. Explaining computers has a great video on the background and development of RISC-V. There are other great videos, for example, on assembly language programming. I highly recommend the Hello World one by Laurie Wired. I'll drop descriptions or links to the videos in the description below. It's 2024 and getting started with an easy to install and use simulator for RISC-V it seems still not that easy. I haven't seen that many videos covering the installation of tools, so that's what I cover here. Let's get going. So I started out by reading this documentation and following this documentation from RISC-V Getting Started Guide. But looks like this is a little bit older and it's actually difficult to get all of this working. I got a lot of it working, but still it was a lot of work. And also, depending on the operating system you have, you notice that some of it there's no Windows, so you'd have to use like a Linux emulator. And then the Mac OS requires installing Brew, which not everyone has installed. So what I decided is to use a cloud based approach where we'll do it in a Linux, in an Ubuntu system in the cloud. And this is by no means an advertisement for DigitalOcean, but a lot of these cloud providers, DigitalOcean, Azure, AWS, they provide some free credits that you can use. And I found that probably DigitalOcean is the easiest for me personally, and I think it's good for beginners compared to AWS. Research AWS free tier. I know the AWS free tier is good. You get about 1 year worth of free things, but still, it can be difficult to set up. So I decided to go with, in this demo, with DigitalOcean. If you search for DigitalOcean with credits, you have to go to a link where they give you this credit for 60 days. So if you do that, you do have to provide a credit card. So I already did that and registered my account in DigitalOcean. So if I sign in, so once I'm inside DigitalOcean, if you have the free credits, then you'll see that you have this free trial active. You could register with a new email address so that you get this free trial, but you do need a credit card to kind of enter over here. And then what I recommend doing here is using droplets. So if I look here, create droplet, then I used Ubuntu 23.10 and the full gigabyte, 120 gigabyte. So this $32 per month. So that's what I used. And once you create this droplet, let's see, let's create a droplet. Or actually, I think I'm already in the create droplet. So you need to put in a password. If you lose the password, I think you can recover it through your email address. But if you create a password that you can remember, or use a password manager so that you don't need to reuse passwords, then you can use a SSH key, but for beginners, probably it's easier to do it with this password based method. So once I create a password, I'll add some of this metrics just because it doesn't cost me much. And then I think I already created this project before. If not, it might say starter project or something like that, and then you might need to rename the project if you want to. And I will name this QMU RISC-V RISC-V demo 2 because I already created one before, so I name it slightly differently, and then I'll say create droplet. So now this droplet is being created. So it took about a minute to create, and once it's created, I can click on this, and I think I can say access and log in as root, launch droplet console. Then you will be able to log in into this cloud computer. So the first time you log in, it might take a few minutes. So once, I think it took me about 45 seconds or something, and then it loaded. So let me make this a little bit bigger. So once I'm here, I kind of follow different tutorials and combine different approaches to get to a working state. So the easiest one that I was able to follow and get it working with the fewest number of steps is actually this one. So I'll leave a link to this again in the description below. And basically this goes through a number of steps. I had to add a few more steps after this to actually assemble an assembly language program and get it running, but it wasn't too many more steps. It just takes time to download and stuff. So what this does is it actually gets a pre-compiled version of Linux that is made for RISC-V. So if you copy just this part, this cdimage.ubuntu.com/releases, and go to that website, and if you look at the latest one, then you'll see that there's several of these server installed image. There is one pre-installed server image. So RISC-V pre-installed server image. And then over here it says requires copying your own first stage bootloader and relevant DTBs into the image before uses on real hardware, but you can use it on the RISC-V QEMU, and that's what we're going to try to use. And let's see, if I look at this, it kind of gives me a link, and then I'll copy link address and wget that link in the Ubuntu in the cloud machine that I have set up. So the steps we'll be following are to create a cloud computer instance. We already did that, and then inside of that we will install QEMU tools. So we'll see that in a bit, and then also after that we will copy a pre-built version of RISC-V Linux, and then there's several steps to that. Then we'll run that inside of that cloud instance, the RISC-V Linux, and then inside the RISC-V Linux, so this is a Linux running inside of emulated RISC-V computer running inside of the x86 computer. So in the RISC-V emulated computer, we will install build essentials, which has the assembler and such, linker, etc. So, and then we'll try out a demo program, like a simple assembly language program. So let's see how we do that. So let's look at this guide again, and we have sudo apt install with this QEMU related tools, including uboot and OpenSBI. So we won't talk to the details except that we need it, but because we're using DigitalOcean and logging in as root, we don't need the sudo. We'll just do the apt install. Let's see if that goes smoothly. And it says Do you want to continue? It will use about half a gigabyte, or yeah, half a gigabyte of space. So sometimes this can take a long time, sometimes it happens fast, so let's see. So this is not taking too long right now. So that took about a minute for me over here today. And then we want to create this directory called RISC-V, where we will download the image. Let's see, over here, make directory RISC-V, and we'll go to that directory. It's currently empty. And then, so this is an older version. So let's look at this pre-installed server image from cdimage.ubuntu.com, and this is the newest release. We'll use this one, and then if you hover over this, you can get the link, copy link address. And what you need to do is you need to do wget and that link. So wget and that link, and so it's doing stuff, it's downloading that. So that's happening pretty fast also right now. Sometimes it did take a longer time, like 10 minutes or something, but right now somehow my internet or is fast, or because I'm downloading the latest version, maybe it's cached somewhere. And so this one is compressed or zipped, as you can see by the XZ, and we need to unzip it using this XZ minus DK. And what we'll do is XZ minus DK, decompress, and then we will say U tab to get that. And that one also sometimes takes a few minutes. I think last time it took about 2 minutes for me, so I'll pause the video. There's nothing, there's no progress bar or anything to keep us waiting, so that took about a minute for me. And then if I list the directory, you can see that the image file is there, and I can try out some of this to see inside the image if the required files for booting are there or not. Yes, that one's there. And let's try out this one. And maybe because the versions changed, because we downloaded a different version, maybe they put it somewhere else. But looks like between Ubuntu 20 and Ubuntu 23, these are in the same place. So let's see if we can run this. You see that it also passes the Ethernet connection there. So the Ethernet connection of the host is also available in some way inside the new operating system. And you see over here, this file is we need to change this file. And let's see if anything else needs to be changed. I think we're all good till here, so we'll copy till here, and then file is equals to U tab. Well, I couldn't do the tab, so I will copy it from here. So I have that whole thing, and I also need the comma format equals to raw, and interface equals to virtual IO. So over here, format equals to raw. So let's see if the QEMU is able to run that. Okay, so something's happening. Ubuntu, okay, looks like Ubuntu is booting. and I'm able to boot into Ubuntu. It's taking a little bit of time, and last time I did this, I think it took a few minutes. Yeah, it does take a little bit of time, so I will be pausing the video until we get everything in the boot done. So it actually took 739 seconds, so a little more than 10 minutes, maybe 11-12 minutes. And then the first login is Ubuntu, and password is Ubuntu. And then when you do this the first time, it asks you to change the password. So I will use one of my other passwords for now. Let's see if it accepts that. Oh, it's asking for the current password. Sorry, so I have to do that again. Ubuntu. And then it wants to change the password. So yeah, the current password is again Ubuntu. And then I'll put in a new password. I don't know if it took that new password or whether when I pasted it. Okay, it did take that new password. So it's taking a while to do this. Remember that we are emulating a RISC-V processor inside of a x86. And this is all open source software, so there's probably a lot of optimizations that is remaining to be done. So we are inside the RISC-V Ubuntu. So let's make sure that it's RISC-V by saying lscpu, I think is the command. So yes, it's a RISC-V 64 byte order little endian. There are actually 4 CPUs, 4 virtual CPUs, and there is a bunch of other information there that we won't talk about right now. And then we want to now see if we have the assembler and ZCC, the compiler. So if I say ZCC version, it probably says that, it'll probably say we don't have ZCC. And the assembler is also not there. So we could do sudo apt install ZCC. I will do build essentials, and let's see, sudo. So because now we are in not root anymore, we are the user Ubuntu inside the virtual machine, where we'll say sudo apt install build essentials. I think it's the same word, though there might be a dash. And then also we will also need to do a sudo apt update, because I think the servers where these are put were different when the build was made versus where I'm using it currently. So let's see. Or maybe it will work. So unable to locate package build essentials. So maybe I kind of misspelled build essentials, or maybe I have to do an update. So let's say apt build essential. Yeah, probably I need a dash. Okay, so let's try that. Build essential. And then it'll probably say that it can't find all the details of that. So it did start, and you can see that it's asking me whether I want to install this. and then it's trying to get it's actually installing the RISC-64 RISC-V64 version, because it already knows that it's in that processor architecture operating system, so we didn't have to specify which one to get. If we were in a x64 computer and then we were doing a cross compilation, we'd have to get the right ones. But I think this is working out. Let's see. I think because I used the latest version of Linux, maybe the addresses were the same, so I didn't have to update the database. And looks like this is going to take a while. I believe last time it again took another 5 to 10 minutes, so I'm going to pause the video for a bit. So after about 10 minutes, I got this, and let's see. Oops, I think I can just say okay. I usually just say okay, and this is in a cloud instance, it's not a production server, so let's see if after it installs everything. So when it installs stuff, it sometimes wants to make sure that it restarts some of the system services so that everything works as expected. So looks like finalizing that is also taking a little bit of time, and service restarts being deferred, so no containers need to be restarted, no VM guests are running. So I think this is almost done. So it's actually, we're inside of one of the inside of QEMU, and so because it's emulating that RISC-V computer, I think that's why it's taking a little bit of time. So now we are done. Now if we say gcc version -- version, then we can see that gcc is installed. Let me see, as -- version for the assembler. So GNU assembler. So, and actually the assembler was configured for target of RISC-64 Linux GNU. And that's exactly what we need. So let's actually write a simple program here from this Lorry Wired Hello World program that I mentioned earlier. It's a very short program, so I'll just type it. So vim, I will say test. Actually, I'll create it in a folder. So let me say make directory test, and let me say vim test.s. .s is the extension for assembly language programs usually in Linux, and we will say dot global underscore start and dot section dot text and underscore start li a0. Again, Laurie explains what's going on here, so I won't repeat it. I'll just copy the program here. li a7, I believe these are registers, and then we do a system call through eCall. And let's so we created this file called test.s. Now let's assemble it through the assembler as test.s, and we'll put the output in test.o. So now if we run the so we need to link it first. So see ld test.o into test. So LD no such file or directory. So the linker was not found. Maybe it's called something else. So I don't know what happened there last time. So I think LD does exist. So I think I have to put -o test. I think that's what happened. So LD test.o -o test. So it created the program called test, and if I do ls -la, you see that the test is executable. And if I execute the test, it does nothing except that we are outputting 2 through the system call 93. So to see the output, I think we do echo $what, and we see that we get that output 2. Now if we edit the program, let's edit the program, and maybe let's output 5. Then we should see that it outputs 5. So if we run it right now just like that, then it will still output 2 because we haven't assembled it and compiled it. So let's assemble it. So let's I'm using the up arrow to go through the history, and we assemble it over here like this. It replaces the test.o. So the test.o has a different timestamp now, but test still is older. So if I run the test again, it's still the older program, so it still returns 2. But now if I link test.o and create the new test, then now if I run test, it should output the new program. So you should be able to write simple assembly programs, or in fact programs of arbitrary complexity here. You can see that a whole Linux operating system is running inside this emulator. So this can be a pretty powerful development tool. So instead of using just a simple simulator, what we did here is to use a whole system that can grow as you grow with it. But there might be some hiccups as you transfer this to hardware, but then because it's a whole system, I think it may be a lot more flexible than using just a shallow simulator. So thank you so much for sitting through this long video with a lot of technical jargon and details. So I'll be bringing a lot more engineering videos with a focus on details and getting things done. So keep an eye out for future content. Thank you.